I'm Nicholas Naclerio from Honeybee Robotics, which is a subsidiary of Blue Origin now. And I'll be presenting on HBEE and POCCET. These are actually two different payloads, but they're sister payloads, which is why I'm presenting them together. But they're sister new Shepard payloads to study bubble formation in viscous fluid and pneumatic regolith trenching in lunar gravity. So next slide, please. So some background here, these two payloads flew on New Shepard 29. This is Blue Origin's reusable rocket, and this was a very unique flight where the rocket went up, the crew capsule separated, and then the entire crew capsule rotated so that all 20, 30 something payloads experienced simulated lunar gravity for 2 minutes. So again, it's a very unique flight and a unique opportunity where we get lunar gravity for much longer time than you could have on something like a parabolic airplane flight. Go ahead and continue. Next slide. So Honeybee actually flew 4 payloads on this flight. On the left, that payload is HELIOTECH, which is a geotechnical experiment. In the middle is HBEE and POCCET, which I'll be talking about today. And on the right is Lunar Anchor, which is a plant root-inspired anchoring device. And pictured here is Monica and Madeline, our 2 engineers who built these payloads. Next slide, please. So I'll give you some background here. So HB, this experiment was to observe bubbles basically in corn syrup. It's called HB, I think honey bubbler excitation experiment. We actually originally started out with honey, but it wasn't clear enough, so we switched to corn syrup. But we basically have this setup shown on the left. We have a tank that holds our corn syrup and a method to deliver nitrogen to the bottom, and the bubbles float up through it. What's special about this one is we were looking at bubbles in viscous fluid. This is corn syrup as opposed to something, like water or a coolant or something. In this case, we're specifically interested in bubbles for molten regolith electrolysis. I'll kind of explain that a little bit later. But you can go to the next slide.
It's like a slow break.
These are some of the results here. On the left, this video is bubbles in 1G, and on the right is the bubbles in 1/6 gravity. Maybe you can repeat that slide so the videos play again. But
It's like a slow break.
what we're looking at here is sort of how these bubbles scale with gravity. Our first point is that velocity.
Is it venting out of there? Is the pressure just...
It's like a slow break.
the solenoid? Is it venting out of there? Is the pressure just...
Sounds like we lost our speaker. Nicholas, can you hear us? Technical difficulties. Bear with us, everyone.
Oh, hello.
Nicholas, can you hear us?
Yeah, I'm not sure where we dropped off. Can you go back to the last slide, please?
We saw the bubbles. We were here.
Okay, yeah, so we got these points. Basically, you can see the bubbles are much larger and much slower in 1/6 gravity. You can go to the next slide. So POCCET, this experiment, the reason I'm presenting both of them at the same time is that the hardware is actually almost identical. And so POCCET was almost the exact same setup, but in this case, we're introducing our nitrogen gas into kinetic sand. So the kinetic sand is a mixture of silicone oil and sand, sort of as a simulant for lunar regolith. So the point here is that the shared design between these two payloads saves a lot of resources. We did not need to reinvent our payload. You can go to the next slide. And in this one, the 2 videos on the right, there's 1G and 1/6G. It's kind of hard to see here, but you should be able to notice in 1/6G, there's much more lofting and sort of circulation of particles. And on the bottom of those pictures, that is a view from the bottom of the cylinder. And in 1/6G, the sort of pneumatic borehole is noticeably larger, 27% larger. Some of the points here is that in reduced gravity, we get a lot more lofting. Essentially, cohesion is playing a larger role relative to sort of gravitational forces, and our pneumatic trench ends up being much less stable. Again, sort of limited to this confined geometry. But some sort of conclusions you could get here is that pneumatic excavation on the moon, you'd be lofting a lot more regolith, sort of expected. Also, a downside, your rocket plumes would again be excavating more regolith in lunar gravity. None of these are necessarily sort of groundbreaking results, but sort of adds to it. You can go to the next slide. Sort of the whole point of these testing is sort of to test some hardwares, test some science experiments, and they sort of contribute to some of our flight programs. For example, HB, this was a study of bubbles in viscous fluids and helps inform the design of molten regolith electrolysis systems. So Blue Origin has been working on molten regolith electrolysis, where you basically melt the regolith and you're trying to extract oxygen from it. You can see in this video here, there's bubbles. And again, kind of what we'd shown in 1/6 gravity, your bubbles will be slower and larger. And so you'd have to account for that. POCCET, we're looking at pneumatic excavation. Due to various delays in the launch, this launch ended up happening after our flight experiment. But the shown in this video here is Lister, one of our pneumatic drills that flew on Blue Ghost Mission 1 to the moon, where we essentially use a form of this pneumatic trenching technology to deliver a thermal probe into the surface of the moon. Honeybee is also working on various other pneumatic sampling systems, pneumatic drilling, etc. That's where this experiment helps contribute towards the design and knowledge of that system. You can go to the next slide. Yeah, that's kind of a conclusion here. Again, we flew 4 different payloads, but this talk is just a very brief overview of HBEE and POCCET, studying bubble formation and pneumatic trenching. And a point here is that these payloads all share a lot of the same hardware, which helps us design different experiments quickly and for lower cost. And again, I'd like to thank the NASA Flight Opportunities Program for funding these flights. Thank you.